All right, let's take a look at exercise 3.4, or the solution for exercise 3.4 for your homework. So we're asked, let's build upon exercise 2.4. So that was our friction factor code um, that I wrote for our chapter 2 solutions. Build upon your script to plot F versus Reynolds for a given value of relative roughness. That is, make your own Moody chart. Cool. For the purpose of this question, write a script where you loop over Reynolds values over the range 1 times 10 to the 3 to 1.1 times 10 to the 3. For each Reynolds, compute F for the case of relative roughness of 0.1 and 0.001 and plot. Plot the results for the two cases of relative roughness on separate plots, and be sure to add a title and axis label. All right, cool. And this is chapter 3. And so if you're not in the class, we haven't started to discuss vectors or anything of that nature yet. And so I'm in my command window, and then this friction factor M file. This is what I wrote in the screencast for our chapter 2 solution. And so in this code, we had a precondition where in the command window, user could specify a Reynolds number of relative roughness, and then this would return the corresponding friction factor. Okay, so what I'm going to do is I'm going to take this code, and I don't want to overwrite it, so I'm going to save this as friction factor and maybe plot. And this is going to be the code that I'm going to use as my starting point. Okay, I'm going to maximize it. And the key is I know that this currently works where if the user specifies a given value of Reynolds number and relative roughness, that it will compute the corresponding friction factor. Okay, so what I'm going to do is I'm going to start by, I'm not going to have any preconditions. Okay, so I'm going to just start by defining a relative roughness. Okay, and maybe this is case 1, relative roughness. In the relative roughness, the first case is ED of 0.1. Okay, so I'm not going to have a precondition of relative roughness. I define ED here. Okay, then in terms of Reynolds number, okay, I'm just going to start by defining a Reynolds number of 1 e to the 3. Right, we're going from 1 e to the 3 to 1.1. Okay. Oh, my face is in the way here, and I don't know how to move my face. Shoot. So, sorry about that. So in terms of maximizing, the problem is my face up here, so I might not maximize. So I'm just going to save this and run it. Okay, looks like we get some results. Okay, I haven't broken my code. Life is good. Okay, so preconditions are going to be none. Okay, this works. But what I'm going to do next is I'm going to loop over my Reynolds numbers. So let's see though in terms of our calculations. So define ED, my relative roughness. Lambda and tau, those are independent of Reynolds. Lambda 2 and tau 2 are both also independent of my Reynolds number. Okay, the only term that's dependent on my Reynolds number is this calculation here of friction factor. Okay, cool. So what I'm going to do is let me add some lines. And so now I'm going to have looping over range of Reynolds numbers and computing F. Okay, so the basic command is going to be for, and we can set this up any way we want. We can actually use Reynolds as my loop index variable. For Reynolds is equal to, and we're going 1 e to the 3 to 1.1 e to the 3. Okay, so I'm going to loop over Reynolds, and then I'm going to compute the corresponding friction factor. Okay, and that's it. So I'm going to keep it at that for now and see if I print out a bunch of friction factors that are changing for these different Reynolds values. And I should add that I could include all of this material within the for loop, but it's unnecessary since it's independent of Reynolds. the values won't change, and so it doesn't necessarily need to be computed each time. All right, so these are only a function of ED. This part's the only part that's dependent on Reynolds. So if I run this now, all right, so what should happen is I should get the friction factor plotted a ton of times with our different Reynolds values. Okay, cool. Okay, next step, so it looks like this is running. So I'm going to add a semicolon here. I'm going to suppress the output. And then the next thing I'm going to do is I'm going to add my plot command. And so when I define my relative roughness of 0.1, okay, now I know I'm going to have multiple figures, so I'm going to start by opening up a figure 1. Okay, and I'm going to clear that figure in case there's something there currently. So I'm going to activate figure 1 and make sure it's cleared. And then I'm going to use my hold on command so I make sure that as I plot a new set of data, the previous set isn't removed at all. Okay, so I'm going to activate figure 1. I'm going to make sure that any data that's on there is cleared if I had forgotten to close it before. And then I'm going to turn on my hold on so that MATLAB won't delete each set of data as I plot a new one. And then figure 1's the one currently activated. Okay, if I forget, okay, I can always make sure I'm specifying figure 1. Okay, and then I'm going to plot my x variables Reynolds, y variables friction, and I'm going to plot those as black circles. Okay, now this is unnecessary, right? Because I activate figure 1, and between here and here, I don't go and activate another figure. Okay, and so I could delete this, but it doesn't hurt if I include it either, right? And so it could just be helpful in terms of making sure the figure I'm writing to is in fact the figure I'm writing to. Okay, so opened up in a new tab, but there it is, right? There's my plot for that case. Okay, so that looked good. Friction factor was also printed, and that's because I didn't suppress it. Okay. So that's great. And so what I'm going to do now is after I've plotted all my data, it could be here or it could be up here. Okay, but I'm going to format my plot now. Okay, because the instructions tell us to add axes labels and a title. So my X label, which is my x-axis label, that's my Reynolds number, so RE. Okay, my Y label, so actually let me just type out Reynolds number. Okay, so I think if I wanted the parentheses, I could do this. I could make it a string with double quotes, and then that's okay. Then the Y label is relative roughness. No, Y label is my friction factor. Bam. So that's my X label. That's my Y label. Title. I'll specify the relative roughness. And there's commands, so we could take our variables and convert them to strings, but for now I'm just going to type it in. So if I save it and I run it, then I have this beautiful plot, right, for case 1. So for a relative roughness of 0.1, I've got my friction factor versus Reynolds. Cool. Okay, now I want to do this. I want to do the exact same thing, but with a relative roughness of 0.001. Okay, so what I'm going to do is I'm going to start by copying this. All right, so we called this case 1. Okay, so now I'm going to take this. I'm going to copy and paste. Okay, so now the second part, right, I've got case 1 up here. That's fine. But now I'm going to look at case 2. And case 2 had a relative roughness of 0.001. 0.001. Oh, I can delete that comment now. And then I'm going to plot case 2, not in figure 1, but in figure 2. Okay, so it'd be the same thing. I'll activate figure 2, and I'll clear it just in case it was open from another run. I won't erase other data points. Okay, lambda 1 and lambda 2, they don't need to be redefined, they're just constants. But whether I keep them or I delete them, it really doesn't matter. It's totally up to you. But this could be deleted, or you could keep it just to keep track of everything on your own. And again, while you don't need to delete them, they're just constants, so the value wouldn't have changed from case 1. Okay, lambda 2 and tau 2, those need to be recomputed with this new value of ed. So those both need to be there, right? Because I've updated the value of ed, so I need to rerun these or re-evaluate them with the new value of ed. And then I'll loop over Reynolds, okay, where now these have the updated value of ed in them, and then this is the updated value of ed, and I'll loop over my Reynolds again. Okay, but what will change is it's not figure 1, right? It's figure 2. Okay, cool. And this is where if I didn't have it, right, it's figure 2 that's activated. Doesn't make much of a difference. Okay, and I could use black circles again since it's in a different figure, or you could change that up if you wanted. X label and Y label is the same, but now my relative roughness is 0, 0, 1. Okay, and if I save that, all right, now I have a figure 2 and a figure 1, relative roughness of 0.1, relative roughness of 0.001, friction factor versus Reynolds, and that's exactly what we were asked to do. Okay, so we looped over those two cases of Reynolds, looked at the two different values of relative roughness, and plotted the results, labeling. And so that is all that would be needed for your homework. Okay. Now, side note, right, it is a good habit to get into saving your figures. So while figure 1 is activated, okay, and I could put a figure 1 up here if I wanted to as well. Right, it's a good habit to use a savefig command. So savefig will save my figure, this is figure 1, as a MATLAB editable file format. So it'll be a plot in a MATLAB format that I could open and edit. And so maybe I want to call this, I don't know, case 1. So F for ED 01. Remember, I can't use periods, dot fig. And I need to put that in quotes, single quotes or double quotes, so it's a string. I could also print. Okay. And if you forget the file formats, you could do a doc print. But if I want to save as a PNG, it's a flag-D PNG. And then the name of the file and the flag can come before or after the file name. And I'll use the same name, but a dot PNG. Then once I get it there, I'm going to copy it. I'll paste it down here. Maybe I'll make this, put 2 more zeros in there, put 2 more zeros in that there. So now if I run it, save and run, oh, I broke it. So it says my print command, it's because I spelled print wrong. So the code broke up here because I didn't spell print correctly. Okay, save it, try again. Now I have figure 1, I have figure 2, and over here I see fig 1. Oh, there's fig 1, there's fig 2, and there's the two different image formats. So with the PNGs, right, you see the preview down here, but if I right click to open outside of MATLAB, well, I'll open in my default image viewer on my computer. Okay, that's cool. And then the way the fig formats work is I'm going to start by closing figure 1 and closing figure 2. And so if I were to double click on this, right, I get a new figure 1 window with all of that data still on there, and I could do the same thing for figure 2. Okay. And so that's it. All right, and so once I have this working, I'm going to save this because in chapter 4 we're going to build upon it. Oh, and actually post condition, not even necessarily going to have a friction factor. So I'll have plot of F versus Reynolds for two different cases of relative roughness. Okay. So I'm going to save this code because in chapter 4, I'm just going to update it further, in which I save my friction factors to a friction factor vector. Then I'll plot the entire vector. So I'll have a vector of friction factors, vectors of Reynolds numbers, and I'll plot F versus Reynolds. I'll use a for loop, then I'll use element-wise operators to simplify it even more. And yeah, but this will be my starting point. And then last thing, so remember the lambda 1 and tau 1, after it's defined for case 1, all right, I'd get the same result if I deleted it. And what I often do is rather than delete things, I'll just comment it out. Okay, commenting it out so that this way if I run it, if it behaves, like I expect it to and it's safe to delete, I could go in and delete. But by commenting out, as if I make a mistake, right, it's easy enough to come in and uncomment. All right, just like this figure 2 command is unnecessary since I'm not messing with any figures after the command, right, that comes up here of activating figure 2. All right, so I could just as well do that here, okay, but I can't mess with that. Okay, and so running, I get exactly the same thing. So I hope that helps. If you have any questions, let me know. I'll post this M file along with the video, so you have that. And if you're not able to solve it, right, this is what I'm going to use as my starting point come chapter 4.